2025년 국제우주산업 콘퍼런스가 글로벌 우주항공 수도 경남 공존과 성장의 미래를 열다 경상남도, 진주시, 사천시 한국우주기술진흥협회 제경남테크노파크 많은 시청 바랍니다. 구독과 좋아요는 큰 힘이 됩니다.
이어가 보도록 하겠습니다. 하나 에어로스페이스 글로벌 사업팀의 이어 해외 우주기술 사례 발표 세션을 시작해 보도록 하겠습니다. 모두 자리에 착석해 주시길 바라고요. 이번 세션에서는 유럽과 아시아 그리고 북미 지역의 주요 우주기술 기업들이 그들의 최신 기술과 또 글로벌 전략을 공유해 주실 예정입니다. 자, 첫 번째 발표자의 무대를 보실 때 마찬가지로 큰 박수로 환영해 주시기 바랍니다. 이탈리아를 대표하는 지구 관측 기술 기업 트레 알카미라의 알렉스 말슨 박사님 무대 위로 모시도록 하겠습니다. 말슨 박사님은 위성 영상 기반의 지방 변형, 분석 및 재난 재해 모니터링 기술을 개발해온 전문가입니다. 쌀 데이터를 활용한 다양한 도시 인프라 감시 솔루션을 제공하고 계십니다.
Governor, Mayors, distinguished guests, good afternoon. My name is Alistair Belson and I am the Asia Area Manager for TI Altamira. I'd like to thank CASP and KTSAT for the invitation to come and speak today. So, my talk is about satellite INSAR for accurate ground subsidence and slope instability monitoring for disaster prevention, and we use 3 different bands of radar satellites in order to do this. So just a quick word about TI Altamira. We were, at the beginning, back in 1999, we were actually a spin-off from the Polytechnic University of Milan. And we have just celebrated 25 years, and over the last 25 years, through dedicated research and development, we have improved our INSAR algorithms in order to catch the most accurate displacements and monitoring of ground movement through time. So my goal today is to explain what INSAR is and what the applications are and how it can be applied here in Korea. So as the name suggests, INSAR is an acronym, Interferometric Synthetic Aperture Radar. So that means that we are using the radar part of the electromagnetic spectrum, and thanks to the space element, many of you are here today. Without your radar data having been launched on satellite platforms back in 1992, we as a company, and indeed an INSAR industry, would not exist. So thanks to your imagery, we have managed to put that imagery together and create maps of movement on the ground through time. So that's the interferometric part. The satellites are acquiring every few days. It's not a real-time monitoring system, but we take a stack of data that's been acquired over a period of time and simulate the stationary satellite over, let's say, Seoul or this building, when in fact actually color measurement points, and each of those measurement points tells us to the millimeter how the ground has moved through time. So, for those of you who have not heard of INSAR before, you might be thinking, how can a satellite see a millimeter of movement on the floor, on the ground? Well, in fact, through the, let's say, scientific calculations and the number of publications that have been processed, it is perfectly viable. And that's exactly what we're trying to achieve here. We are creating maps over any area in the world to very, very high precision. 25 years of research and development has allowed us to get to this point, but our key goal in offering these maps, and there are various different, let's say, sectors where we can apply this data, is to provide ground displacement information, allowing for the long-term and remote identification of ground, infrastructure and slope instabilities before they become critical. So the applications are plentiful, and I will go through those in the next few slides. So, like I mentioned, we were born in 1999, and over the last 25 years we've developed really leaps and bounds the type of technology and the data sets that we can actually get. Again, partly thanks to the space sector. Without your improvements in the satellite platforms and the sensors on board, our technology would not have come forward. On the other side, our algorithms have got significantly stronger and better, more powerful, along with the computer systems, and most of our data is now actually processed in the cloud. And now we can process from single buildings with very, very accurate, high density of measurement points over a single area, all the way up to entire countries, or indeed even with our latest European ground motion monitoring service, entire continents of ground movement through time. We were bought by a French company called CLS, which is in part owned by CNES, which is the French space agency, back in 2015. And when we amalgamated with one of our competitors at the time, we became the world's largest INSAR group. And between the CLS offices, which we have 30 around the network, around the world, we can service multiple countries through time, and also thousands of projects. And here is a picture of the number of INSAR references for publications on our technology over the last 25 years. So if you haven't heard of it, it's definitely an established technology with growing attention. So as TRE, as a company, we have now processed commercial projects in over 70 countries worldwide, over 10 million square kilometers of ground. Bear in mind, this is a very complicated processing technology, so it is critical to calculate and then remove errors. There are errors in satellite wanders, the position of the satellite itself. Obviously, the radar signal penetrates from space and hits an object on the ground and then bounces back to the satellite. So there are multiple ways where errors can come in. So really getting the most accurate analysis is critical. And we've done over 1,000 projects in over 70 countries worldwide, including here in Korea. So we actually acquire movement information along what we call the line of sight. So we can't look directly vertically. If we look directly vertically, then all the radar reflectivity would come straight back to the satellite at the same time, and would be very confusing to calculate. So all of our satellites are actually right-looking. As you know very well, these satellites are in low Earth orbit, and they're on north-south polar orbits. So they only pass over the same area every few days. At the moment, some would consider that a limitation on the technology. But because we are looking to detect millimeters of movement through time, at the moment we don't necessarily need everyday imagery. That would be the dream, and it's very important for us to have very stable orbits for us to be able to process those data sets.